Hello, and welcome. Today, we're opening Chapter 12 of the Handbook of Face Recognition. To make sense of a face, a computer first has to find the parts: the eyes, the nose, the mouth. 88 tiny points, and they need to land in under a tenth of a second. The chapter is built around 6 questions. Where are the eyes? What's the framework? How do we fit the landmarks? Does any of it actually work? And what comes next? Let's start at the very beginning. Where do landmarks actually help? First, face recognition. You compare two faces by lining up the points. 3D reconstruction. These flat dots become the seeds for a full 3D model of the head. Cartoon or sketch. Trace the points and you get a stylized drawing. Pose estimation. Figure out which way the head is turning from the landmarks alone. Expression analysis. Read a smile or a frown from where the points move. And beautification. Every modern photo filter starts right here. Start with the obvious fix. To find an eye, search the box where an eye should be, and take the darkest spot. On a clean, front-facing photo, it works. Then the real world shows up. A shadow falls across the face, and the edge it locked onto is gone. The head turns, and the eye slides straight out of the box. The face moves closer, then pulls away, and the box stops fitting at all. Illumination. Pose. Scale. One rigid box, 3 ways to break. The answer isn't a better box. It's knowing what a face is, its shape, and the few ways it's allowed to move. That's the framework we build next. Every method in this chapter shares the same skeleton. First, detect the face. Then, crop. Then, find the points. And finally, refine. Only the finder step changes. Everything else stays the same. The shape model is built on a simple idea. Every face is the mean face plus a few learned tweaks. Each tweak is a mode of variation. The first mode usually controls scale. The second, rotation. The third, expression. Keep about 15 of these modes, and you can rebuild almost any face. Find the eyes first. They're the easiest part to spot round, dark, framed by lighter skin. Once you have them, you have a coordinate system. Scale, rotation, the rough position of every other point, all from the eyes. Here's the whole idea in one line. Any face is the mean face, plus a few learned adjustments. Start with the mean, the average shape, the same for everyone. Now turn the first dial. Mode 1 is width, the face grows wider, then narrower. The second dial is height taller, then shorter. A third opens a smile. A fourth lifts the brows. That's the whole model, a mean shape and a handful of numbers, 1 per mode. Dial them in, and you rebuild any face. You can watch the points settle. Starting from the mean shape, every round nudges them closer to where they belong. Does any of this actually work? Time to measure. We put RFE-ASM head-to-head with a plain active shape model. 3 standard benchmarks: BioID, Ferret, and AR. First, accuracy. On every dataset, the refined method lands closer to the truth the bars climb higher. And it isn't slower for it. Side by side, RFE-ASM fits a face in less time on a single CPU thread. Now zoom into the points. The error drops across almost all 88 of them, not just on average. And the cumulative curve rises sooner. More faces solved inside a tight error budget. More accurate and faster. That's the result. So that is the chapter. A shape model, a neighborhood pattern, an iterative search. Together, the engine of face geometry for over a decade. What did we deliver? Real-time, landmark fitting on standard frontal faces. What's still unsolved? Big head turns, heavy occlusion. And what's next? The deep learning wave the authors could already see coming. Chapter 12 was written in 2011. Here is what happened in the 15 years after. 2011. Shape models still held a throne. Beautiful, interpretable, but slow on anything that wasn't looking straight at the camera. 2012, 2013. Cascade regression took over. Instead of fitting a shape, the model just learned to jump. Each step, every point, moved closer to its target. 2017. FAN. Heat map convolutional networks. Instead of pointing at one pixel, every pixel gets to vote. The brightest spot wins. Profile faces and occlusion that broke the old methods finally solved. 2020. MediaPipe. 468 dense points. A full-face mesh. Running on your phone at 30 frames per second. The technology behind every modern face filter. 2022 and beyond. Full 3D mesh. Recovered from a single photo. Identity, expression, head pose. All separated, all controllable in one model. 3 poles. Accuracy, interpretability, real-time. No method holds all 3 at once. Choosing 2 out of the 3, that is still the central design question. 6 papers, 15 years, 1 rabbit hole. Chapter 12 sits right in the middle of this trajectory, the bridge between the classical era and everything that came after, where landmark localization started, and where it's going.